Okay, this is going to be a video about free body diagrams. Oh, so exciting. Meow. Okay, so what the heck is a free body diagram? Well, physics people are actually really particular about how they draw force diagrams. So let's say I've got this truck right here and I'm trying to pull it like this across the table. And I want to draw a diagram to try to describe the forces that are acting on it. So one way we could think about it is maybe just kind of drawing it from a side angle like this and pulling it like that. So let's just draw a picture, and I'm going to sort of show you what some of the issues are in drawing force diagrams. So here's the truck, big wheels on the truck, and then there we go. Okay, so there's our truck. Let's see if I can adjust this exposure. There we go, that's a little bit better. So there's our truck, and we want to draw the forces that are acting on it. So let's say I have the rope attached over here, so there's the rope, and then there's the ground right there. I'm still not happy with that exposure. There we go, that's a little bit better. And I want to kind of draw these forces that are acting on it. So I've got the rope kind of pulling it from over here, so I kind of want to draw like the rope with the little force arrow over there. And I've got gravity pulling down somewhere. So I'm going to draw gravity, but where's gravity acting on the truck? Because it's kind of like it's pulling all over on the truck. So do I draw like a lot of arrows for gravity, or do I just draw one arrow for gravity? I don't really know. And maybe there's some friction, but the friction's acting on the wheels. So maybe I'll just draw this as like gravity. And I'll put this as tension over here. And it's getting a little messy, and now I've got like friction here. There's got to be a normal force that's pushing up, but that's on the wheels, right? That's the force from the surface. So I'm running normal in here, and you can see it gets a little bit busy, and it's hard to see what's going on everywhere. So here's how we do what's called a free body diagram. To simplify things, you take the object that you're trying to draw the forces on, and you simplify it, and you just draw it as a dot. So rather than drawing this truck, I'm just going to draw a dot. There's the truck. Now I'm going to draw all the forces that are acting on the truck as just coming out from this one dot. It's kind of simplifying it, and they're all going to act just from this spot. I also want to draw the forces kind of coming out from the dot instead of going into the dot. So up here I've got gravity, and rather than trying to figure out where it's actually acting on the truck, I'm just going to draw it right down there like that, gravity. And I'm going to label this as, maybe make it a little neater, Fg for gravity, like that. I also know I have a normal force. Remember, normal force is anytime you've got something resting on a surface, then there's a normal force pushing up from the surface. So I'm going to have this coming up like this, and I'm going to label that as Fn for normal force. Now I have the rope that's attached to the truck also that was pulling it this way. So I'm going to draw an arrow out from here, and I'm going to label that as maybe T, or maybe I'll label it as Ft for tension. And then probably there's some friction acting as well, and so rather than trying to figure out where's the friction acting at what point, I'm just going to draw it right there, and I'm going to just label it as F with like a little F like that for friction. And this thing is called a free body diagram. Now it's actually really easy to see all the forces that are acting on something here, right? And I can also break things down into what's happening in a up and down direction and a side to side direction really easily. And I can see what's happening in either direction without really having to try to figure out where they're acting. So this thing is a free body diagram. When we draw free body diagrams, we want to kind of follow some simple rules right here. So here's the simple rules. First of all, we're going to draw the object as a dot, which we did. We're not going to draw any other objects. So up here, I'm not going to actually draw the rope. I'm not going to draw the ground. I'm not going to draw anything else. I'm just going to draw just the truck as a dot. I'm going to draw forces as vector arrows originating at the dot. So here's my vectors, one for each force. Yep. I'm going to label them with the type of the force, which I did. For forces that are strange or different, just make up your own label, like push. Like, for example, if I had been pushing on the truck from here as well as pulling on it from here, I might add in another force over here that's a push. So and this is actually interesting. How do I label two forces in the same direction? If I'm pushing on the truck from over here, I'm just going to go ahead and draw in another arrow from right there. And I'm just going to label this as F push or something like that. And you can make up whatever labels you want to put on them. Is totally fine. You want to pay attention to the direction. So obviously the directions are going to be really important. You want to pay attention to the length of the arrow. So I want to draw the length of my arrow in proportion to the strength of the force. And right here I haven't done such a good job because it looks like my gravity is a little bit bigger than my normal force. And if that were the case, I'd have some acceleration in the downward direction. I don't really want that to happen. So probably should clean this up a teeny little bit. I should probably have my normal force vector be the same length as my gravity force vector. Okay? I'm only going to draw the forces acting on the object. So I'm not going to draw my hand over here, or I'm not going to draw the string because the string is attached to the truck and it's actually only acting on the truck. And then if necessary, break down vectors into components. What do I mean by that? Well, let's draw another scenario here. I'm going to show you from the side. Let's say instead of pulling straight this way, let's say I'm kind of pulling up at an angle like this. So if I have a force that's going up at an angle, I can maybe break things down into components. So let's draw another free body diagram where I'm pulling the truck up at an angle. So we still have all these other forces acting here. I can draw gravity going down. I can draw a normal force going up like that. Just maybe friction still acting in this direction. And now I'm going to have my tension going up like this at an angle. And I'll still label it as Ft. What I can do with this tension, we don't really like things that are going off at funny angles in physics, is I can break it down into components, as we did previously when we talked about projectiles. So I can draw one this way and one this way. And maybe I could label this as Ft in the x direction, right? And maybe I could label this one as Ft in the y direction. And that way, when I'm looking at forces, I can see which forces are acting in the up and down direction and which forces are acting in the side to side direction. In the up and down direction, I've got normal force, I've got gravity, and I've got this component of the tension. In the side to side direction, I've got just this friction force and I've got this tension force going that way. So that's just sort of a quick example of free body diagrams and how you might draw a free body diagram. I'll make another video about some free body diagram examples.